In this lesson, we'll look at sort of the theory behind retrieval practice as an effective learning strategy. We're going to use an abstract diagram like this. The box here represents our brain. And of course, we want to store information in our brain as a result of learning episodes. The to-be-learned information could be anything. It could be, the word gato in Spanish is translated as cat in English, or what's the smallest living thing? A cell. So identify that when we're studying information, we're reading or watching a video lesson or listening to teacher, we want to be associating some cue with a target. So the cue would be gato, the target would be cat, the cue would be the question, the target would be the answer. And this is what learning amounts to. And we want to make these associations and store them up in our brain. So we'll diagram that with this link here. Here we have a link between the cue and the target in the brain. And that link was established as a result of the learning episode where we experienced the cue and the target together. Now, we don't want to associate the cue with other distractors, so other bits of information, incorrect pieces of information. So we want the cue to be linked to the target and not linked to other distractors. Now, lots of students have a view of learning that involves getting information into the brain. So the idea in this view is that learning is really just sort of storing this information in the brain. But this overlooks the value of getting the information back out of the brain, what we call successful retrieval. It's not enough to just store the information. We want to have access to that information. So learning is more than encoding or storing information. It is the interaction between retrieval cues in the present and remnants of the past. So consider then, when you take a test questions are retrieval cues. We want the test question to be able to activate the target. If we have effectively learned, the association between the cue and the target, then the test question as a cue should be able to activate the target, and then we retrieve the target. So notice though what learning amounts to. Yes, during learning we set up these links, but we want the links to be there so that later other cues can reactivate the targets. The focus here is on retrieving information. Now, if the target is successfully retrieved, then we would say the learning was successful. And notice, along with this view, a common view of tests is that they are measures of prior learning. So here's the test question, we get the right answer, and so we now conclude that the student did learn the information because they can get the answer to the test question. We're going to see how retrieval, though, can also be instrumental in making that link up in the brain as well. So if experimental data shows that retrieval is a good learning strategy, what is happening when we retrieve? In another lesson on retrieval practice, I go over some of the evidence that retrieval practice really does lead to benefits in retention at longer retention intervals. So what's going on? Why does retrieval practice have this beneficial effect? Well, one idea is that whenever we retrieve information, so we've got some cue, some question or whatnot, and then we're seeking the answer to the question. Whenever we retrieve the target, we actually make the link between the cue and the target stronger. So the current suggestion here in the psychology literature is that retrieval is not just assessing whether the link is present, but each time we retrieve, we're making that link stronger. Now, what's going on here? Well, one hypothesis is that actively retrieved information must be restored in memory. So these are biological processes that are occurring in the brain. When we retrieve information, that information then gets restored. It goes through processing to restore the information, and this process can enhance the long-term memory of the information. The cue-target link gets stronger. So if we do this repeatedly then, if we use cues to repeatedly activate the target, then that link gets stronger and stronger with each repetition of the retrieval practice. In addition, repeatedly retrieving the target also weakens the links to the distractors. So this is like the flip side of the effectiveness of retrieval practice. You are strengthening the links that you want and weakening those other potential distractors that might be incidentally linked in the brain. So it's as if the brain works by the principle that what is retrieved today is probably important tomorrow too, so that information should be stored well in long-term memory. So we seem to have brains that if information is repeatedly retrieved, that information is likely to be important. And so we have brains that strengthen those links with repeated retrieval. And you'll recall in the lesson on retrieval practice, we learned that restudy leads to ease of retrieval in the moment, right? We get the working memory boost and high confidence, but the evidence indicates that it fails to strengthen the links as well as retrieval. Now that's for long-term retention. We did note that there was a cramming effect. So restudying can make information accessible in the short-term memory system for a short time, but long-term retention is best served by retrieval practice. So the act of recognizing or being familiar, right, so just restudying your notes, recognizing or being familiar with the information is not the same as actively retrieving the information. Yet these are common study strategies that are inferior to retrieval practice. There is something about retrieving information that strengthens the link, whereas just rereading the cue target association does not seem to have the same effect on that link. So why is retrieval better than restudying? Retrieving information from memory activates different brain systems compared to rereading. Exercising those retrieval systems more effectively strengthens the link between the cue and the target. In addition, actively retrieved information must be restored in memory, a process that strengthens the memory. Information that is reread may not be processed in the same way. So scientists are still researching this phenomenon. But again, the take-home message is retrieving information is having a larger effect on the storage system than simply rereading the information. Now notice, in a given amount of study time, the restudy strategy may allow the student to cover more material than is possible with retrieval practice. However, the advantage of coverage is counteracted by the disadvantage of more forgetting with a restudy strategy. So the retrieval strategy may cover less material, but the long-term retention gains can compensate for the selective nature of self-testing. If good questions are used for retrieval practice, the disadvantage can be minimized. Now, we should say a word, though, about what happens when we fail to retrieve. We don't want to see this in a negative light. We want to see the positive side of failed retrieval. Because scientists think that when we fail to retrieve, you have the question in front of you and you can't think of the answer, that sets up the brain for reprocessing the association. So failed retrieval can enhance the brain's readiness to process the cue-target relation in future study sessions. And when we fail to retrieve, it's sort of like our mind is saying, wait, what was that information? What is the answer? So, and then if we restudy that association, the brain is prepared to make an attempt to store that again. So failed retrieval does a couple of useful things. It gives us a sense of whether we can effectively access information. So it's good for calibrating our metacognition. It's a good measure of how well we know something if we're doing retrieval after a delay. But it also is setting our brain up for reprocessing the information to be studied. Now, if failed retrieval leads to stress, that does become a problem because stress interferes with the retrieval system. So stress is not good for learning. So we don't want failed retrieval to be leading to stress. If it's stressing the student out, then you want to take a break so that you're not trying to study under conditions of stress. So when we think about learning, we want to make sure we're on the road to successful learning. We don't want to be detoured with poor study strategies. As it turns out, many students are using inferior study techniques. It's okay to restudy and rewatch a lesson if you really don't remember anything or you were confused, etc. But you don't want to use large doses of just rereading your notes. You want to build as much retrieval practice into the study mix as possible, along with deep processing. So we want to be on the road towards learning, and we want to use best practices. We don't want to get detoured by using inferior practices. One of the ways that psychologists mention to do deep processing is to make the information distinctive. So when we're learning some question and answer or cue and a target, we want to highlight how that's different from other stuff that we know. And in the brain, the idea is we want to strengthen just the link between the cue and the target as opposed to other kinds of things that might be distractors. We want to weaken these kind of distracting links and strengthen only the cue-target link. We want to make new pieces of information distinctive, how they're different from other things that we know. In addition, we want to practice retrieval in ways that you'll be tested later. Now, it's a common phenomenon that when we study, we might have a question and an answer, but then on the test at a later time, the question is worded a little bit differently. So we want to be mindful of that when we're studying information, we want to also incorporate into our study different kinds of cues that we want to associate with the same target. Knowing full well that the questions we have in our kind of review packet might be a little different than the question that ends up on the test. So we want to be aware of that fact and prepare appropriately. We want to practice retrieval in ways that you'll be tested, and sometimes the test questions are worded differently or have a different sort of emphasis, and we want to be mindful and we prepare during our study sessions. In summary, then, retrieval practice has several benefits. One, there's clear evidence that it is superior to other types of study techniques. We think that it's superior because it is more effectively strengthening those links between the cue and the target for long-term retention of information. And in addition, retrieval practice is a good metacognitive tool. It's a good assessment of long-term retention if it's done after delay, and even if we fail to retrieve the information, that sets up our brain for further processing.